welcome to Virtual CB1A. This is Miss Rena, and for today's lesson on descriptive statistics, we're going to talk about measures of dispersion. Let's start with the learning objectives. At the end of this lesson, you were expected to know the different methods of finding the measure of dispersion and, of course, compute for the measure of dispersion of a given dataset. First, let's answer the question, what is a measure of dispersion? It measures the extent in which a given dataset is spread out around the center. If you still remember the methods of finding the center, those are through the mean, median, and mode. It gives an idea on how sparse or squeezed a dataset is. If you notice that your computed value is large, then the data is widely scattered around the center. Otherwise, it is tightly clustered. And you have to take note of this. The lower the measure of dispersion is, the more consistent the data points are. Now, what are the different methods of finding the measures of dispersion? First, we have the method of finding the range. We can also compute for the standard deviation. And finally, the coefficient of variation. There are other methods of finding the measure of dispersion, but we are going to focus only on these three. Okay? So let's start with the range. What do we mean by the range? It is the difference between the maximum value and the minimum value. When we say maximum value, it is the highest number in your dataset. And of course, for the minimum value, that is the lowest number or the smallest number in your dataset. So what are the pros and cons of finding the range? For the pro, it is the easiest to compute. And a disadvantage is it is very sensitive to outliers. So we have here the formula for the range. It is equal to maximum minus the minimum. Okay? Let's continue. The next method will be the standard deviation. It is also a measure of dispersion, of course, and it measures the average deviation or departure of the individual scores from the mean. So this is mean-based, average-based. We have two formulas for the standard deviation. The first is when you are going to find the standard deviation out of a given population. So you're going to use the square root of the summation of x observation minus the mean squared over n. So here, x is the observation, although I have already given you the meaning of these variables. Next, we have the standard deviation. Of course, it is also a measure of dispersion. It measures the average deviation or departure of the individual score from the mean. So this is average-based. For finding the standard deviation, we have two formulas. One is if you are going to find the standard deviation out of a population. The next one is when you are given with a sample. So take note, they only differ in the denominator. When we say capital N, it is the number of observations in the population. And for small n, this is the number of samples. And for x, although I've already mentioned the meaning of these variables, on our previous lessons, X means observation, while X bar means the mean. And for our standard deviation, we have two notations. We use this for population standard deviation, while we use lowercase s for sample standard deviation. Now, what are the disadvantages of getting the standard deviation? It is, of course, more difficult to calculate. You can see from the formula that it is more complicated than the range. And also, it depends on other statistical measures. So, it depends on the mean and also the n, or the number of samples or the number of observations in the population. Now, what will be the advantage of getting the standard deviation? It is not as affected by outliers as the range. And also, it gives a more accurate picture of how the data is distributed. Alright, now let's go to the third method. We have the coefficient of variation. It is also known as the relative standard deviation. It is commonly used to calculate or compare the dispersion between two variables with different unit of measurements. So, for example, to compare the dispersion between height in inches and weight in kilograms. Since height is length, while weight is mass, it is difficult to compare the two data sets. So, even if the height has a greater range or standard deviation compared with the weight, we cannot say that it is more dispersed than the weight since they use different unit of measurements. So that problem can be addressed by the coefficient of variation. This is our formula for the coefficient of variation. Again, we have one for the population and another for the sample. So let's look at the notations. I've already introduced to you these two notations. We have here this Greek letter. This corresponds to the population standard deviation. I'll just write here SD kasi tamad ako. And then for S, we have the sample standard deviation. Now, for this other Greek letter, mu, this is the population mean.
Ring, ring, ring.
And for this notation, this is the sample mean. I know you're already familiar with this, but if in case na may nakalimot sa inyo, ayan, mariremind kayo. Now let's proceed to the examples. I will skip this one because I will give this as an activity later. Let's look at the other example. We have here the height in inches and the weight in kilograms. First, let's look for the measures of central tendency. Measures of central tendency for the height. Kasi kailangan natin siya for the standard deviation and also for the weight. And then after that, we're going to compute for the range, the standard deviation, and the coefficient of variation. Okay? Alright. So, sabi ko nga kanina, unahin natin ang mga measure of central tendency nila. Since ang kailangan natin for both the standard deviation and the coefficient of variation is the mean, so let's get the mean. So, what is the average or the height average? We have 63 plus 60 plus 68 plus 70 plus 61 plus 63 plus 62 plus 69 plus 68 plus 66. Now, how many observations do we have? We have 2, 4, 6, 8, 10. So, all we're going to do is to divide the numerator by 10. So, please get your calculator. Mas maganda kung sinasabayan nyo ko para hindi kayo litong-lito. Now, let's add them up. We have 63 plus 60 plus 68 plus 70 plus 7, hindi pala. Plus 61 plus 63 plus 62 plus 69 plus 68 plus 66. Okay, all in all, we have here 650. 650 pala. Hindi pwedeng ilagay yung word na end. Kasi end means decimal point. So we have here 650 divided by 10. Obvious na naman, di ba? The average height is 65. Ayan. Now, let's get the average weight in kilograms. Again, we're going to add all the values. 55 plus 49 plus 85 plus 90 plus 52 plus 54 plus 55 plus 80 plus 79 plus 52. And then divide everything by 10. Kakapagod itong ginagawa ko. 55 plus 49 plus 85 plus 90 plus 52 plus 54 plus 55 plus 80 plus 79 plus 52. Oh, lumamang lang ng isa. We have 651 divided by 10. So we have here 65.1. Okay? I hope that was clear. Kasi this time, we're going to compute for the range. So, kunin natin yung mga range nila. Ano nangyayari sa ballpen ko? Yan. Range tayo ng height muna. So, di ba sa range naman, ano lang siya? Maximum minus the minimum. So, si height, ano yung maximum height? Sino yung pinakamatangkad? 63, 60, 68, 70, 61. Okay, si 70. Minus, locate natin yung pinakamaliit. 60 na ba? 60. Okay, the range here is 10. While for the weight, ano ang range ng weight? Lagyan natin ditong R off. Baka mamaya malito. R off. Yan. Range of height, range of weight. Highest, 80. Lowest? May 90 pa. Okay, highest niya pala ay... Oh my God! Nagulat ako sa'yo. Ha? Oo, nagulat lang ako. Ha? Okay. Yung? Ha? Hindi makapag-intay? Okay lang. Gulat na gulat. Let's find the maximum weight in our set of observations. So the maximum weight is, alright, that is 90. Minus, what is the minimum weight? The minimum weight will be 49. Now, what is the difference between 90 and 49? Okay, so the difference between 90 and 49 is, of course, 41. This time, let's compute for the standard deviation. Okay, while we are recalling the formula for the standard deviation, balikan muna natin yung discussion natin dito sa range. If we are talking about the height, then medyo pwede na tayo mag-settle for the range. Kasi wala naman siyang outlier. But for the weight, if you will take notice, sobrang laki nung difference, 41 between the highest and the lowest. So, parang may outlier dito. May sobrang mabigat, tapos meron ding sobrang magaan. So, hindi normal yung distribution natin. If you have an outlier, sabi nga natin kanina, since the range is very sensitive to outliers, you will opt with another measure of dispersion. Kaya ngayon, puntahan naman natin si standard deviation. Although, sabi ko kanina, it is okay to settle with the range for the height. For the sake of example, i-compute na rin natin yung standard deviation ni height. Okay? Alright. So, do you still remember the formula for the standard deviation? We have two formulas for the standard deviation. One is for the population and the other is for the sample. So, dito, lagay na lang natin as title. Ay, ano nangyayari sa pambura ko? So, to make it even more clearer, para mas makapag-decide kayo kung ano yung kailangan yung gamitin, lagyan natin ng title tong table. Hindi ko pala siya nalagyan earlier. This is the height and weight of 10 randomly selected students. So the fact that they are randomly selected means that they were taken from a bigger population. Therefore, sample lang tong 10 ito. So we are going to use the formula for the sample standard deviation. That is the square root of the difference between the x observation minus the mean squared all over n minus 1. So what is our n? Our n is, of course, 10. And what are the values of x? So the values of x are our observations here, 63, 60, 68, 70, 61, 63, 62, 69, 68, and 66. Medyo mahaba-habang computation to. Okay. We have 63 minus our mean. Our mean here is 65. So, 63 minus 65. Tapos, i-square mo siya. Plus, summation siya eh. Yan, summation. Plus 60 minus 65. And then their difference will be again squared. And then you will repeat the process. 68 minus 65 squared, 70 minus 65 squared, 61 minus 65 squared, until you reach 66. So plus, and so on, plus 66 minus 65. Kulang kasi ako sa space, kaya ginanyan ko na lang. Papakita ko na lang yung difference niya sa baba. Okay? And then, we have n minus 1. That is 10 minus 1. Or, syempre, 9. Sabi ko kanina, papakita ko siya. So, s is equal to the square root of Yan. 63 minus 65, we have negative 2. Dito, wala kayong excuse. Baka sabihin nyo, hindi kayo marunong mag-subtract ng integers. Kasi, lagi tayong may squaring function. Anything that you square will be positive. So, it doesn't matter whether you forgot to put a negative sign in your difference. Kahit na maging positive yan or negative, when you square them, para sila ng sagot. So, plus 60 minus 65 is 5 squared. Plus, doon na tayo sa pangatlo, 68. 68 minus 65 is 3. So, 3 squared. Doon naman tayo sa pang-apat, 70 minus 65. We have 5 squared. Plus, 61 minus 65, we have 6 squared. Plus, 63 minus 65, again, we have negative 2 squared. Kakasya kaya? 62 minus 65, we have negative 3 squared. Plus 69 minus 65, 5 squared. Plus 68 minus 65, edi, 3 squared. And finally, we have 66. 66 minus 65 is 1 squared. I hope you can still see the solution, kahit na medyo hirap na hirap tayo sa space. And then, the difference between 10 and 1 is 9. Now, let's simplify. We have here 2 squared is 4. Tama? Tama. Plus 5 squared is 25. Plus 3 squared is 9. Plus 5 squared is another 25. Plus 6 squared is 36. Plus 2 squared is 4. Plus 3 squared is 9. Plus 5 squared is 25. And then 3 squared is 9. And then 1 squared is 1. And then divide everything by 9. Okay, now let's get the sum. Get your calculators, please. 4 plus 25 plus 9 plus 25 plus 36 plus 4 plus 9 plus 25 plus another 9 plus 1 and 2, 4, 6, 8, 10. Tama. We have here 147. So the square root of 147 divided by 9. 147 divided by 9. That is approximately equal to 16. Purahin ko lang para mas malinaw. This is approximately equal to 16.33. So this is the standard deviation for the height. Now, let's go to the coefficient of variation. Okay, bakit hindi ko sinagutan yung weight? Bukod sa tinatamad na ako, hindi. Itong weight, this is going to be your activity. So, I will be writing it down mamaya doon sa classwork nyo. By the time I finish uploading this. Now, let's go to the coefficient of variation. CV of height. Okay. So, si coefficient of variation, para mahanap natin siya, meron tayong dalawang requirement. kailangan alam natin kung ano ang value ng ating standard deviation, and at the same time, you have to know the value of your mean. Given ba tayo dun sa dalawa na yon? Yes, alam natin kung ano yung value ng dalawang yan. Kasi na-compute na natin sila kanina. So, what is the value of your mean? The value of your mean for height is 65. What is the value of your standard deviation? The value of your standard deviation is 16.33. So, if you have these two values, all you have to do is to substitute it to our formula here. The coefficient of variation is equal to the standard deviation for the sample and the mean multiplied by 100. So, in terms of percentages nga pala, itong CV. So, we have 16.33 divided by our mean, which is 65. Tapos i-multiply nyo siya by 100%. Ito, hindi ako makapagsulat ng maayos naman. Kuha tayong calcu. Ay, nag-exit. $16.33 divided by 65. We have approximately 0.2512. Multiply na natin siya diretso sa 100. We have 25.12%. So the coefficient of variation of height is 25.12%. Okay? So that will be the end of our discussion. Now, for your assignment or for your classwork, all you have to do is to get the coefficient of variation of the weight and the standard deviation of the weight. So, hindi naman kayo makakapag-compute ng coefficient of variation ng weight na hindi nyo dinadaanan yung standard deviation. And, teka, hindi ko pa pala siya pwede i-cut. Kasi, tuturuan ko kayo mag-compute using the Excel. So, let me just exit this presentation, then I'll be back with the Excel book.